Sorry, students. Wait for a few minutes. Sorry for the delay. There was a technical issue again. Once again. Sorry guys, sorry for that so much delay. Hello guys, welcome to the physics section, everyone. So, in motion in the chapter, motion in a plane, we'll discuss now the last concept and very important concept in NEET point of view is relative velocity. Relative velocity, right? I hope you guys are getting the voice clearly. Right, okay, fine. Yeah. So first of all, what is relative velocity? Relative velocity of a moving body is nothing but the velocity of that body with respect to some other body. That with respect to one another body, we are telling that may be in motion or may be at rest. or you can say with respect to a frame, with respect to a frame. So we can usually we say relative velocity means relative velocity, relative velocity. So velocity, relative velocity means velocity of a body with respect to another 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 body. That another body may be in motion or it may be at rest also. So for example, in general I will give you a formula for measurement of relative velocities. So in in general in general relative velocity of body A with respect to another body B is given by we express it as like V A B. Here, as we are calling relative velocity of A, or simply you can say velocity of A with respect to B also. When you say velocity of A with respect to B, A will be the first body and B will be the second body. So, in such case, we express the general expression as VAB is equal to velocity of the first body, that is A, plus reverse velocity velocity of A plus reverse velocity of B. VAB, that is velocity of A with respect to B, is equal to velocity of A, the first body, plus reverse velocity of B. So this is the general formula you guys have to keep in mind and remember while dealing with the calculation of relative velocity or measurement of relative velocity. So let us see some cases, simple cases here. Some cases. Example, like an example. If two bodies, A, there are two bodies, body A and body B. Now here body A is moving with velocity VA towards right and body B is also moving towards right with velocity VB. Then with the different velocities and VA is not equal to VB here. VA not equal to VB. Okay, in such case velocity of A with respect to B when they are moving in same direction both, and by sign convention you have to remember that. So if this is a Cartesian coordinate system, x-axis horizontal line is x-axis, vertical line is y-axis. So and if this is origin, this will be positive x, this will be negative x, this will be positive y, and this will be negative y. So well, when if you say VAB, velocity of A, as A is moving towards right, we consider this as along a positive x direction. We take the VA, velocity of A is positive. VA plus VA or simply VA will be in this direction. Means it is moving in positive x direction. Reverse velocity will be in negative x direction. So plus of reverse velocity of B will be minus VB. So here we will take this plus of minus VB is directly can write minus VB. So if two bodies are moving in same direction, relative velocity of the first with respect to second is nothing but VA minus VB. Simply you can remember that VAB equal to VA minus VB when the bodies are moving in same direction. Same direction. With the help of example I am giving you. Without much theory sentences, you can note down this. Whereas if you have, this is body A moving with velocity VA towards right, and there is another body B, it is moving with the velocity VB in opposite direction. This you can also consider this way: A is moving with velocity VA towards right, and there is a body B is moving with velocity VB in opposite direction. Means if two bodies are moving towards each other, in such case, or if the two bodies, that is A and B are moving away from each other. So this is VA and this is VB. If they are moving away from each other also, if A and B are moving away from each other, so in these cases they will be moving in opposite directions, towards or away, opposite directions. In such cases, let us say this in first case, here in first case, VAB is equal to velocity of A. Velocity of A is in positive x direction, so VA plus, just a second. Yeah. Here B is moving in negative x direction. So its reverse velocity means if you reverse it, it will come in this direction. So it is already in the negative direction. So reverse of this will be in positive direction. So VA plus VB, reverse velocity of second body will be in this direction. This is the velocity of A with respect to B when two bodies are going in opposite directions. We have to take the sum. So if whereas in this case, this is in first case, whereas in second case, VAB is equal to A is already in negative direction. So we have to take minus VA plus of reverse velocity of B. B is in positive x direction, so the reverse velocity will be in minus negative direction. So minus VB, VA minus VB. So you can take this as minus of VA plus VB. So the net velocity will be in reverse direction. I mean negative direction. So towards left. That is how you have to understand this. So velocity, relative velocities. So that is briefly how to deal with the relative velocity part. Relative velocity part. Okay. Now here let us see some special cases like rain umbrella problems, and we can also call it as rain man problems or rain umbrella problems, and river boat problems. River boat problems. Say first case we'll consider, let us say rain umbrella problems. Rain umbrella problems. What is this rain umbrella problems? The first, let us try to understand this with the help of some examples. First one, let us say if the rain, if it is raining vertically downwards, or you can say rain is falling vertically downwards with a velocity, if it is raining vertically downwards and rain is falling vertically downwards with a velocity Vr. So Vr is a velocity of rain with respect to ground, you can say. Nothing is there means with respect to ground. So if rain is falling vertically downwards and there is a man who is moving towards right, so you can say we can represent the velocity of the man as with a vector, as this is the velocity of man. Let us say this is velocity of man. Okay, if a man is moving with velocity Vm towards the right, then and if he is holding an umbrella, if he is holding an umbrella if he is holding an umbrella to avoid the rain, in what angle with respect to vertical or horizontal he has to hold the umbrella is the question. So, or you can say what is the velocity of the rain with respect to moving man, or velocity direction of when he is moving, what should be the direction of fall of the rain with respect to man? These kinds of questions you may come across based on this concept. So first, if you come across this term V, that is velocity of rain, usually with respect to ground, if you are standing on ground, if you are observing on the ground, the rain is falling down, right? And if a man is moving by holding an umbrella, for this guy, the moving man, so you can say velocity of rain with respect to a moving man or with respect to a man is equal to usually velocity of rain Vr plus reverse velocity of man. Velocity of man is towards right. Reverse velocity will be in this direction. in this direction. So this will be minus Vm. So we have to take it as Vrm is equal to Vr minus Vm by general formula of relative velocity. Yes or no? So by vector notation, you can say velocity of rain with respect to man is equal to velocity of rain vector form minus of velocity minus velocity of man minus velocity of man. Okay. Yes. So pictorially, how can you express? So that how can you understand this angle? Let us try to understand. So pictorially, we can express this as, so velocity of rain. Rain is falling down actually. This is velocity of rain. Vr. Velocity of man in negative direction. This is velocity of man. Vm. So negative. What is that? Negative component of Vm is nothing but we can say minus Vm will be in this direction with the same magnitude same is with the same length of that line we have to take. So this will be minus Vm. So this is first vector, this is second vector. If we take this, these are two sides of the vector, what do you call it, triangles. The closing side gives the resultant. The closing side taken in reverse order. This will be the resultant. Here our resultant is nothing but velocity of rain with respect to man. Vrm will be in this direction. Means when a man is moving by holding the umbrella like this, is moving when rain is falling down. When rain is falling down, when he is moving, the rain up, instead of falling down because of its motion, rain appears to be falling at some angle. Rain appears to be falling at some angle like this. So he has to hold the umbrella. So as a, if you hold the umbrella like this, rain will be falling on him in this direction. So he may get wet. He is the person which may get wet. So to avoid that, he has to hold the umbrella in this direction. Right, with respect to vertical, at what angle you may ask. So this will be the direction of Vrm. So it can be given like this. So if you know Vr and Vm magnitudes, magnitude of velocity of rain with respect to man is equal to square root of Vr square plus Vm square, gives you the magnitude of velocity of rain with respect to man. But right, but at what angle it has to turn the umbrella to avoid from the rain with respect to vertical or with respect to horizontal. If you ask, if you say this is vertical, with respect to this, if you are if he is rotating through some angle theta, let us say, if this is theta, this also will be theta. If this is theta, if you take tan theta, theta or alpha in symbolic use, tan theta is equal to opposite side by adjacent side. So opposite side is Vm. So we have to take a modulus of Vm by adjacent side is Vr. So by Vr, the values of this if you take, then you will get that tan theta. From this you can find out the theta value, that is the angle through which it has to, when it is moving, it has to rotate the vertical, it has to rotate the umbrella front side towards front. Okay, so this is what you have to understand. So this is one of the case of rain umbrella problems. Rain umbrella problems. The first case. Okay, when rain is falling down, the man is moving with velocity. Whereas in the second case, you have to understand, just to note down these points and note down this point here. And this initial case. So this is what you call when it is moving with respect the velocity of rain with respect to moving man. Or man is nothing but this one. It will be in this direction. So umbrella should be holding in this direction instead of vertically. If it is standing, then he can hold like just like vertically up so that he can avoid the rain. But when he is moving, he has to rotate the umbrella at an angle theta with respect to the vertical. Whereas what is the angle of this with respect to horizontal? If you ask, with respect to this, if you take this is alpha, and tan alpha is equal to opposite side by adjacent side, that is Vr by Vm will get, the reverse way will get. So tan alpha with respect to, where alpha is the angle of the umbrella with respect to horizontal, will be tan alpha is equal to the V modulus of Vr by Vm, where alpha is angle of the umbrella with respect to horizontal, theta is angle of the umbrella with respect to vertical. So these points you have to remember. Next, another case, second case. If this is a vertical, there is a person who is holding the umbrella, or you can say just a person is standing. Now a person or a man is moving with a velocity Vm towards right. And here, to understand, let me take the first velocity of rain. Here the rain is not falling down vertically. So with respect to vertical, rain is falling at this angle theta with respect to vertical. At this angle theta, this is velocity of rain. Now the man is moving with a velocity velocity Vm, let us say in this case Vm1, let us say for understanding purpose, or Vm1 to compare the other cases you can take this Vm. Now the velocity of rain with respect to moving man, already rain itself is making some angle with respect to what do you call the vertical. So in this case, as if you are standing, if the rain is falling from backside like this at some angle, so to avoid the rain you have to hold the umbrella like this when you are standing. But when you are also moving, in such case what will be the direction of your umbrella, or what will be the velocity of rain with respect to moving man? If you are asked, velocity of rain with respect to man is equal to velocity of rain plus of reverse velocity of man, that means minus v velocity of man in vector notation. Velocity of rain will be same we have to take, but reverse velocity of man if we take, this will be the reverse velocity of man, right? So this will be the reverse velocity of man, means minus Vm1 or Vm, you can take Vm1 or simply Vm also you can take. Now this is velocity of rain, this is velocity of man. Resultant will be in this direction, this will be the velocity of rain with respect to man. So this will be making an angle alpha with respect to vertical. Is it clear? So in this case, still it is not in vertical. Still we have to hold the umbrella at this angle of alpha, which is different from theta. So this kind of what you call special cases we may come across based on rain umbrella problems. And even if you increase the speed, that means if the speed of the man increases, so that he feels like when he is moving, even though rain is falling at some angle, if when he is moving he feels like the rain is falling vertically downwards, for that the velocity of the man should be increased further, so that it has to come to this point, then the resultant velocity will be in this direction. So so that is another case. That is another case. If you increase the velocity of man further, I'm not giving those cases, just I'm giving you orally to have an understanding. So if you understand this, then you can follow those points. So if you do some numericals, then you can understand this. We'll do some numericals one or two afterwards. So if the speed of the man is increased further, so that the reverse velocity will be going behind this vertical line, then resultant velocity will be in this direction. Means umbrella direction will be from this from the backside direction. You have to hold now. You have to change the direction of umbrella like this towards front side only. So like this we have to change the direction of umbrella depending on the direction, depending on the speed of the man, provided it is raining at some angle with respect to the vertical. This is how you have to deal with this kind of questions. Whereas now let us see another case related to this relative velocity concept, that is river boat problems. Another very important concept, guys. Try to understand this carefully. Write down the subheading. After discussing this, we'll do some numericals. Okay. River boat problems. River boat problems. Riverboat problems. And one more thing here, in this second case, if you want to know the direction of the umbrella, you have to take tan alpha. If this is the direction of here, the resultant velocity direction, so that means you have to hold the umbrella, in this case this one. This will be the umbrella direction. So with respect to vertical, what is this angle if you are asked to find? By symmetry, this is alpha, so this will be alpha. This is alpha, means this will be alpha. So tan alpha is equal to opposite side by adjacent side. This adjacent side, we can take this as here. If this is VRM cos alpha, VRM sin alpha, you will get. So tan alpha is equal to opposite side will be this. So if this is actually in this entire thing, if you take this is VR not VRM component, VR cos theta, VR sin theta also we can take it as. So this is VR sin theta minus this term, that is what do you call VR negative term of EM. So opposite side will be this minus this, that is this entire thing is the vertical component of ER, that is V R sin theta component, it should be. So V R sin theta, you can also call it as X component, Y component also. So if this is X component of ER, this Y component of ER, then you can take VR sin theta as Vx. So VR sin theta minus Vm divided by this will be, this is opposite side, adjacent side will be VR cos theta. VR cos theta, this can be expressed as, this is, if you take this is x axis horizontal, so this can be taken as the x component of ER. So Vx minus Vm by Vy. So in this way also we'll take to find the direction of alpha, right? Now river boat problems. Here we'll come across two special cases, guys. River boat problems. First case, shortest distance path, motion of boat in shortest distance path, shortest distance path. So for the boat to cross the river in shortest distance path, how to deal with the corresponding terms or relative terms. So let us consider, this is the river and width of the river is D, and this is one bank of the river, this is another bank of the river. Now here, so to cross the river in shortest distance, the shortest distance is nothing but the width of the river. If let us say this is the initial position of the river, point A. To cross the river in the shortest distance path, he has to cross in this vertical position. But when river is flowing with a velocity Vr, if if a river is flowing, river water is flowing, if you drop some cardboard or if you drop some leaf on the water, it will move automatically. If you keep your boat in the river which is flowing, it automatically it will flow along with the river. So if you want to, if you start in this direction to reach this, the river will drag you, so you will not reach this point, opposite point. If you say this point is big, so to this path, a vertical path, a straight line path is started the shortest distance path. To exactly to cross the river to and reach this point, opposite point B, the boat has to start its motion at some angle like this, at this angle. So if you say this is the theta, so this is, if you say this is the velocity of boat with respect to river, if it start in this direction, then as river is pulling like this, by the end, by the time of it, slowly it crosses, it is moving, it is crossing like this, it will be crossing, and by the time it reaches the point B, it will exactly, it will be it just reaches the point B. By the time it moves in this direction, it will move slightly, and it reaches the point B. So this kind of motion is called shortest distance path. So to reach this exactly shortest distance path point or exactly opposite point on the bank, the boat has to start at an angle with respect to the vertical. So if this is VBR, you can say this is VBR. So VB is, yes, it is making an angle theta with this. So you can say its component along this will be VBR cos theta, and in this direction component will be VBR sin theta. River is flowing in this direction. We can say this is, you can take this is the velocity of river with respect to ground, that's the velocity of river. Now, if you want to find what is the time taken by the boat to cross the river in shortest distance path, the time taken to cross, time taken to disconnected temporarily. Now it is reconnected back. Now it is reconnected back. Yeah. Whereas the another, so you may ask this one. Okay, the time taken to cross the river, so by giving the width of the river and the component and that angle also. Okay, whereas the second case in this here is the shortest time path. So that means to cross the river in the shortest possible time, how the boat has to cross, so we call it as the shortest time path. Shortest time path, shortest time path. So that means if you to understand this, so let us consider the same scenario. This is the river, one bank of the river, another bank of the river. So on this bank, let us consider a point A here, and here exact opposite point B. To cross the river, in shortest time. So if the boat, if it starts as the river is flowing with velocity vr, the river automatically drag it. If it is start at some angle, it may take more time to cross this. But if you consider this is point B, if it start exactly in this direction, perpendicular to the direction of river flow, if this is a river flow, perpendicular to the river flow, if it direction, if it starts, the boat, the velocity of boat with respect to river, as river is flowing in this direction, it may drag it, and by the time it reaches the other bank, it may reaches this point C instead of B. So but here the boat is moving in some velocity and the river is also dragging it, so quickly it may reach the other bank of the river. So that's why this path is called shortest time path. So to cross the river in shortest time path, the boat has to start its journey perpendicular to river flow. This kind of conceptual point of questions also you may come across. To cross the river in shortest time path, in what direction the boat has to cross? The boat has to start it has to start sailing. Boat has to start sailing in perpendicular direction, in this direction, perpendicular direction to the river flow. So this is a conceptual question. So here, and instead of reaching this point, it reaches this point C. Let us say this distance is x. We call this distance is drift. We call this distance is drift. So of course, if you take this as width of the river is d, then what is that time taken to cross the river in shortest time path, you may ask. The time taken here is nothing but of course distance by uh, velocity. So velocity with which it is the what do you call the velocity with which the boat is traveling is VBR, and of course at the what do you call um, velocity of the boat with respect to river, with respect to river VBR. So as river velocity is also moving in this direction, so VBR plus VR together will drag this. So that's why it will travel distance this. So but here, to travel along this distance, the component of velocity which is dragging here is only VR. So we have to take this component as not VBR, VR only. So d by VR we have to take. So whereas the drift, if you take drift, that is a distance is equal to velocity into time. That is drift. The drift is nothing but the distance bc traveled is equal to velocity into time. Velocity with which the boat has traveled to cover this distance into time, right? So we can take this time over here, and the velocity with which it is trying to cross that this component, particular component you have to consider here, then you will get the drift value. So the corresponding velocity into the time, if you substitute, you will get the drift value. Okay, so now let us try to work out some numericals based on these points, so that you can understand a little more clearly. Let me take some questions here. Based on relative velocity, relative velocity, some simple questions. Motion under gravity, motion in the plane. Yeah, motion in a plane. Yes, guys. Just a second. Already in the morning session, we have discussed some more questions based on the projectile motion. Yeah. Let us take one simple question here. Yeah. So the question, let me dictate the question. Try to copy this question, guys. The question is: a boat moves perpendicular to the bank. A boat moves perpendicular to the bank with a velocity of a boat. This is a bank, river bank. A boat moves perpendicular to the bank with a velocity of 7.2 km per hour. Velocity of boat with respect to river is 7.2 kilometers per hour. The current carries it 150 meter downstream. Instead of, if you say this is point A, this is point B, so instead of reaching this point, the current, water current drags it in the downstream, means in the direction of flow of the water to a point C. So through a distance x, we call it the drift. So that a drift is nothing but 150 meters in the downstream. Downstream means along the flow direction. Find the velocity of the current. Velocity of current means river current. Find the velocity of current, or current means velocity of river. Find velocity of river provided. The width of the river, if you take, this is the width of the river is d. So width of the river is d is equal to d. Width of the river is 0.5 kilometers. 0.5 kilometers. 1 kilometer is 1000 meters, so you can write it as 5.5 to 10 power 3 or 500 meters. So how to find this? By using our conceptual discussion, how to find velocity of river. Just now we have discussed it, right? So options, you can let me give you the options also. The first option is zero point 0.4 meter per second. Second option is point sorry 1 point, so 1.2 meter per second. Third option is zero point 0.5 meters per second, and fourth option is 0.6 meters per second. Yes, guys. Yeah, let's try this. So you have the formula here, just how we have discussed it here. You have the formula already, right? Now try this now. Try this now. So we know that, you know, you can say that what is this? What you are asked about velocity of river. You know the what you call the drift x is the distance is equal to velocity to time. Velocity to time. Here this velocity is nothing but, so the drift is taken by velocity of river, so or velocity of water, right, into t. So you're asked to find vr. So vr, from this you can say vr is equal to x by t. Here the drift is given, x is given, the time taken is not given, but width and this VBR are given. So you can say here from this, but where t is equal to time taken to cross in the shortest time path, we can call it as, it is t is nothing but, time is distance by velocity. What is this distance here? D by velocity of boat with respect to river actually. This actually here I can take one small correction part here. We have taken this is a t is equal to distance velocity of boat with respect to river. Velocity of actually time taken to cross this in shortest time path is nothing but a distance traveled, is nothing but width by velocity of boat with respect to river. And here to travel this drift, travel this drift, you have to take the velocity of the current, that is the river current, into the time. This time will be this, so you can also write it as br into, what is this, d by vbr The same formula I can make use here. So in this case, first find out time t, and as x is given, substitute the values. Or directly you can substitute all the values. X is how much? 150 meters. All should be in a single same system of units. T is d. D is how much? For 500 meters by VBR. VBR is how much? 7.2 kilometer per hour. So by means it comes here 7.2 kilometer per hour. If you want to convert this into meters per second, because all are in meters, these are in meters. So they can write it as 5 by 18 meter per second, because the options are in meters per second. So you have to convert this. Simplify now. Then we'll get, what will get? 0, 0, 5, 5 ones, 5 tens, and let's do these calculations by yourself. You can write it as you can write 15 into 72 by 100 into 18 and simplify further. So what is this 17? You can take um, 72 by 18, how much? 7.2 by 18.4 into 15 is equal to 6 by 10.6. So zero point 0.6. Is there any such option? Fourth option. Fourth option. Yes, right. So fourth option, zero point 0.6. It will be 0.6 meter per second. So calculations you have to develop. The habit of doing the calculations quickly, guys. Okay. So this is how you have to find out. You have to do this kind of questions. Right. Next, let us do one more simple question. Let me see if there is any question based on riverman problems. Riverman problems. Okay. So next question, let us see quickly. Yes, guys. So what is this? Next one. One second. Let me give you just another this related question. I hope you guys have copied this. Those who have not copied it, copy quickly and try to understand this. Go through once again, read once again properly. Yeah. So note down one such related question. Yes, guys. Next question is: raindrops are falling downward. Raindrops, raindrops are falling downward downward at you can say the raindrops are falling downward at 2 kilometer per hour speed. 2 kilometer per hour speed. Full stop. For a person moving forward, for a person moving forward at 1.5 kilometer per hour feels the rain falling at feels the rain copy it everyone quickly. Feels the rain falling at. What does it mean? Feels rain falling at. So the rain drops are falling vertically downwards, and this means this is velocity of rain. Let me draw the pictorial representation for this. The rain is falling down vertically down. This means velocity of rain VR. So VR is equal to 2 kilometer per hour. And for the person moving forward, means a person is moving, a man is moving, velocity of man is moving forward, means to the rightwards, you can say velocity of man is equal to 1.5 kilometer per hour. The man who is moving forward feels the rain falling at what velocity? If he is just simply standing, he feels that rain is falling vertically downward only. But because he is moving, he may feel the rain is falling in a different direction. What is that? So that means what is velocity of rain with respect to moving man is equal to vector velocity of rain minus velocity of man. Velocity of man. So simply you can say velocity of rain with respect to man is equal to magnitude of this is equal to square root of VR square plus VM square. But in pictorial representation, if you want to represent, you have to take the minus VM. So this will be minus VM. So this will be the direction of velocity of rain with respect to man. If you're asked to find what is the direction, then you have to take with respect to vertical. Then this may be the angle. You have to find this angle, theta or alpha, whatever it is. With respect to horizontal, you have to find this angle. But you're asked to find what? What is that? What is this? Speed or angle? Actually, did I give the options? Note down. Actually, options are given about the speed only. The first option says, you can note down here the options here only. First option is 7 kmph. Second option is 1 kmph kilometer per hour. Third option says 5. Fourth option 25. 5 and 25. 5 kilometer per hour. Fourth option 25 kilometer per hour. So what is this? Is equal to square root of VR square. VR is how much? This is 2 square is 4. Okay, wait guys. Options. I think I am going for another question. Yes, let us check. Actually, VR square. VR square is 2 square is 4. Plus this is 1.5 square. 1.5 can be written as 3 by 2. 3 by 2 square is 9 by 4. So can we write this as 4 into 4 16 plus 9 is 25 by 4 under root. So 25, if it comes out of the root, it becomes 5. 4 comes out of the root, it becomes 2. So it will be what? 2.5. So actually here it is not 5 kilometers. This is the options given for the different other question. These are 0.7 kilometer per hour. This is 0.1 kilometer per hour. 0.5 kilometer per hour. This is 2.5 kilometer per hour. 2.5 kilometer per hour. So it is 2.5 kilometer per hour is the answer for this VRM. Okay, accordingly you have to take. Is it clear, everyone? So note down this. So only speed you are asked to find. Speed of rain with respect to man. Very simple one. If you are asked to find angle, you can take VR by VM. As VR and VM are given, you can take the ratio also. Okay. So this kind of questions will come, guys. So as time up, I'm winding now. So you guys try to practice. This kind of questions. It's the same questions once and similar kind of questions also. Okay. Okay, guys. Yep. So now I'm winding. Take care, everyone. Bye bye. The classroom students, be there only. I'll come there in a minute. Just if you have anything to share, I can talk to you guys in 5 minutes. Be there only for 5 minutes.